No, I really do not like Michigan. Ha! But I do like geometry. So, geometric vector operations. Some qualities in real life are described by scalars, which are numbers which describe the magnitude or size of things, such as quantity, length, height, weight, volume, etc. Vectors describe both the magnitude and the direction of the object or quantity. So a vector describes movement, right? So if I talk to you about, let's say, something that's inanimate, like a pyramid or a building or a tree, um, that has just magnitude. Vectors describe movement. So if we're talking about something moving at 5 miles per hour, that's a scalar. But if I say 5 miles per hour due north, that's a vector. So a vector can be represented by a directed line segment with an initial point, start, and a terminal point, end. So this is a segment with an arrow tip at one end. So it kind of looks like a ray, except it has an end. It stops there at B. It doesn't continue on. If you'll remember from rays, it would be like ray AB, and the point B would be, the arrowhead would be beyond that point. This is vector AB or vector A, or we would just say A in this case. And that would mean that we started at A, at the initial point or tail, and the stopping port is the terminal point or the tip. All right, so magnitude and direction. So the magnitude of vector AB denoted as, it looks like the absolute value of vector AB is the length of the vector from its initial point to its terminal point. The direction of a vector can be expressed as the angle it forms with the horizontal, or as a measurement between 0 and 90 degrees east or west of the north-south line y-axis. So in this case, the direction of vector A is 30 degrees relative to the horizontal. Now, keeping that in mind, okay, here we have another vector. So we could say vector AB is 60 degrees east of north. All right, keeping in mind that north and south and east and west. So if we have this, right, our Cartesian plane, north, south, east, and west. Now, with vectors in the coordinate plane, a vector is in the standard position if its initial point is at the origin 0, 0. The vector can be uniquely described by its terminal points, so point P, X, Y is how we would describe that. Now, there's something in mind with vectors on the XY coordinate plane. So let's say that I have a vector that comes from here and it just travels like so. This angle here, we would measure the angles relative to this direction. So anything going, it always starts here going in this direction. Okay, so let's erase all our ink again and put this back in. So we always start going positive from the origin on the x-axis. So one of the things that would happen is if I have a vector, let's say this is quadrant 1, this is quadrant 2, this is quadrant 3, oops, and here's quadrant 4. So everything up in quadrant 1 is positive, right? Positive x, positive y. Then we go from negative x to positive y, negative x, negative y, and then positive x, negative y in quadrant 4. So when we measure any vector, let's say I have a vector going here. Well, the measurement of the angle is actually going to be from there to there. If I have another different vector, let's say I'll go with green here. If I have a vector there, that one measures all the way across like so. And my final one, let's say I've got one in this quadrant. The actual, when we measure the angle measurement, we would measure it from this point all the way around to this. To describe a vector with any initial point, you can use what's called the component form, which describes the vector in terms of its horizontal component x and vertical component y. The component form is written by taking the coordinates of the initial point, x sub 1 and x sub y sub 1, and the terminal point is always x sub 2, y sub 2, and putting them in the form x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. It is basically almost like putting coordinates. All right, it's the same rule that we would use in regards to that. So here I have vector PQ. So we're going to write this as vector. Let's try it again. Vector PQ. And the way we write this is with kind of looks somewhat like, it doesn't look like a parentheses. So the terminal point is here at Q. So -3 minus -1, comma, -1 minus 3, and we're going to close that off. So vector PQ is at -3 minus -1 becomes -3 plus 1, which becomes -2. -3 minus, -1 minus 3 is -4. So what they're describing here, if we take a look at this, is that this vector went 2 to the left and down 4. Okay, according to this description here. That's the component form. So let's take a look at the next one. So, oops, wrong thing. Erase that. Okay. So, vector CD is, we're ending at D, so it's 4 minus 0, 1 minus -1. And so vector CD would be at 4 minus 0, which is 4. 1 minus -1 is 2. So if you look again, this went 4 to the right, up 2. Okay? So the first number is horizontal, the second number is vertical. Okay, so we're going to be using 2 of 3 things we already know. The distance formula, or the Pythagorean theorem for magnitude, and the tangent for direction. Oh, hopefully this didn't get too messed up. So we're going to use the Pythagorean theorem to find the length of r, the vector r. So 4 squared plus 5 squared equals r squared. And then we're going to say 16 plus 25 equals r squared. 41 equals r squared. So r is equal to the square root of 41. So that's our magnitude. Let's do our direction. So we're going to solve for theta now to start. So theta is this symbol right here. And that's just going to find the measurement of this piece of the angle. Remember, we have to figure this whole thing out here. So let's go back to here. We're going to say tangent of theta is equal to opposite 5 over adjacent, which is 4. So the tangent, now we're going to use the inverse. So the tangent -1 of 5/4 equals theta. So I plug that into my handy dandy calculator here, and I find out that that theta is equal to 51.3402. So we're going to say this is equal to 51 degrees, and that's just theta. Okay, so the vector is going to be 180 plus 51, because we always look at that relationship there. Okay, this relationship right here is what we're coming up with. So 180 plus 51 equals 231 degrees. That tells us the direction where it's going. Okay, it's going all the way down to what we would probably call the southwest. Right? Right? Now, another way of doing that, they might say that it's 51 degrees south of west. They could say that. They could say it's 39 degrees west of south. They could say that too. But this is the mathematically soundest way of doing this. Okay, so now we want to find the magnitude and direction of vector P. So we're going to use, this time we're going to do the distance formula. And so the distance formula here is just going to be d is equal to, actually, we'll just say vector P is equal to the square root of -1 squared plus 4 squared. That's all you have to do is plug it in. And you end up with the square root of 1 plus 16. So that's equal to the square root of 17. Now we want to find the magnitude. Now it might help to draw it a little bit. So we're going to come over here and we'll take a little drawing. And we're going to say that it's going to go up, or excuse me, 1 to the left and up 4. So our vector here, and we'll do this time, we'll do it in red, is kind of going like this, right? It's on this angle here. Now, this is 1, and this is 4. So, what we can do, we can leave this negative off of there, but we are going to use, this is where theta is going to be. So the tangent of theta is equal to the opposite, which is 4, over 1. So the tangent, inverse tangent of 4 is equal to theta, and that'll tell us what theta equals. So we plug this into the handy dandy calculator again, and I get 75.9638. So we're going to round that to 76. Now that's theta. Now remember what we said is that when we do a vector, we're going to do this relative to this here, right? Here's this angle here is relative. So we're going to be actually finding, let me find a different color here. We're actually looking for this here when we describe the vector. Right in there is what we're looking at. So we know that 90 degrees, and I'll draw that straight up and down here, it's going to be like this. And there's going to be an angle in here, and that little angle is only going to be 14 degrees. So I now know that since this part is 90 and this part's 14, the vector direction is 104. 90 plus 14. So, there's our answers again.
That's all, folks.
Hail to the vectors.